Okay, today we're going to derive the reduction formula for the integral of the cosecant to the nth power of x with respect to x. Now, if you've watched my other videos on reduction formulas, with trigonometric functions to an nth power, we always have to manipulate this integrand into a form that we can integrate, and we typically do that by breaking down the powers. So I can write the nth power of the cosecant function as being equal to cosecant to the n minus 2 power by cosec squared of x. And this is simply using the index law that c to the power of a plus b can be written as c to the power of a by c to the power of b. It's just the addition index law. So when we add these two indices, n minus 2 plus 2, it is equal to the nth power. Okay, so if we integrate both sides with respect to x, we can now see that the right-hand side is an integral containing two parts, which implies we'll be using integration by parts. So the first part, we let u equal cosecant to the n minus 2. The second part, let's let dv equal cosec squared of x dx. We can take the derivative of the cosecant to the n minus 2 power, so du on dx is equal to, bring the power down, which is n minus 2. The function stays the same. We subtract 1 from the power, so it becomes n minus 3. Now by the chain rule, we have to multiply it by the derivative of cosec of x, which is equal to negative cotangent of x by cosecant of x. So this simplifies to n minus 2 by cosec to the n minus 2 power, and that's from this term multiplied by this term by cotangent of x, and of course there is a negative now out the front. And if I separate the differentials on the left hand side, I can rewrite this as du equals negative of n minus 2 by the cosecant to the n minus 2 power of x by cotangent of x dx. Now let's work on this side here, dv. Dv integrates to v, and the right hand side integrates to negative of the cotangent of x, by virtue that the derivative of the cotangent of x is equal to negative cosecant of x. Alright, so now that we have both parts, let's apply the integration by parts formula, which is the integral of u dv equals u by v minus the integral of v du. So thus the integral of cosec to the nth power of x dx is equal to u, which is cosec to the n minus 2 of x by v negative cotangent of x minus the integral of v negative cotangent of x du, which is negative n minus 2 by cosec to the n minus 2 of x by cotangent of x dx. So simplifying the right hand side, let's write this as negative of cot x by cosec to the n minus 2 of x minus, the two negatives become a positive. Let's write cosec to the n minus 2 as the first part, then cotangent by cotangent can be written as cot squared of x dx. And I've forgotten, sorry, to write the n minus 2. Let's write the n minus 2 coefficient out the front, and I'll tidy that up a little bit afterwards. Okay, so earlier we established cot squared of x plus 1 equals cosec squared of x. Well, I can write this as cot squared of x, if I rearrange a bit, is equal to cosec squared minus 1. So let's substitute this term for cot squared. So the trailing integral becomes cosec of n minus 2, cosec to the n minus 2 of x by cosec squared of x minus 1. In fact, I'm going to leave the integrand out, the integral out of it for now. We have some more manipulating to do. We can now expand the outside term into the brackets. So the resultant after expanding the brackets is cosec to the nth power of x minus cosec to the n minus 2 power of x. And let's write the rest of the terms down. So we have the integral of both of these terms. We have n minus 2 at the front. We have a minus. Let's bring down the front term here. Negative cotangent of x by cosecant to the n minus 2 of x. Now this integral I can write as two integrals. So we have a trailing integral at the back. So expanding the n minus 2 into the two integrals, we have negative n minus 2 by the integral of cosec to the nth power of x dx plus n minus 2 by the integral of cosec to the n minus 2 power of x dx. Let's copy the front term down, negative cot of x by cosec to the n minus 2 power of x, and the term on the left hand side of the equation is the integral of cosec to the to the nth power of x dx. Okay, so what do we do now? Well, we have a nth power of cosec here and an nth power of cosec on the right hand side as well, and a coefficient at the front. So let's bring all of the cosec to the nth powers to the other side. So on the left hand side we have the integral of cosec to the nth power of x dx plus n minus 2 to the power of, by the integral of cosec to the nth power of x dx, which equals, I'm going to simplify it by factoring out the integral of cosec to the nth power, and of course we have 1 plus n minus 2, which equals n minus 1 by the integral of cosec to the nth power of x, and this is all equal to negative cot of x by cosec to the n minus 2 power plus n minus 2 by the integral of cosecant to the n minus 2 power of x dx. Now all that's left to do is to divide both sides of the equation by n minus 1. So that gives us on the left hand side the integral of cosecant to the n minus 2 power of x with respect to x is equal to negative of the cotangent of x by cosec of x to the n minus 2 divided by n minus 1 plus n minus 2 on n minus 1 by the integral of cosec of x to the n minus 2 power dx. So therefore we have just derived the reduction formula that we were looking for. Hopefully this matches what you see in textbooks. And I'm sorry, I've just made a mistake here. I've realized that this should be nth power, not n minus 2. And remember, n is a positive integer. So give that a go. That will do it for this video. Thanks for watching. If you found it helpful, please share it with your study mates on social media. Subscribe to my channel for future videos. Ask questions in the comments below. Best of luck with your studies, and I'll see you on the next video.